Our D was 25 meters. Then the angle is 210. Using this very large angle here is going to help us in such a way that whenever we compute this, the sign will just come automatically in what direction are we moving. So 25 cos 210 on my calculator, it's giving me negative 21.65 rounded off to 2 decimal places.
Boy,
21.
what didn't
Microphones, please.
love you, try to make it on.
20. Oh,
So my calculator was giving me 21.65 in meters. Then the component of D in the y-axis is going to be D sine theta, which is going to be 25 sine the very angle, which is 110 or 210 rather. At this point, this guy is going to give me, using my calculator, sine with that, it's going to give me negative 12.5 meters. So, because in this question, we were told that the angle was measured from the positive x-axis. From the positive x-axis, reaching up to that point, 210 degrees. So in order for us to find the components in the x and the y-axis without considering the sign, we would use the obtuse angle. This very obtuse angle, the angle that is measured from the positive x-axis. Say we had a different scenario. Say this angle was measured from the positive y-axis. Say it was 210 measured from this point. Let me say, so we just try to modify the question. Say solve the x and y components of the previous question. Say the angle was measured. This should have been measured. This should have been measured anti-clockwise from the positive y-axis. So let me go back to drawing XY plane. So this question, it's now telling us to solve the same question, but with the angle measured from the positive y-axis, counterclockwise. So if we measure counterclockwise, 210 degrees, it will lead us to getting into this first quadrant. So assume that is starting at 0. So this is 210 degrees. So now we want to find the y component. the y component and the x component of this guy. So this is D. So in order for us to swiftly solve this, instead of using this angle, we can safely use this other angle. Yes?
The angle that you draw.
Oh, it's not actually 210, right?
Yeah, and it's not anti-clockwise.
If we measure counterclockwise will be going this way, so that we also remain in the same there. Thank you for that observation. I was actually thinking of other questions. So if we measure counterclockwise, this is this is clockwise. Clockwise is this way, then this is counterclockwise.
It's going to be in the fourth quadrant.
So when we go this way, this is counterclockwise. When we go this way, this is clockwise. So at this point, we are moving from the positive x-axis, coming to that point where it makes an angle of 210, right?
Yes.
210 going in those directions. So means our y component is going in that direction and our x component is going in that direction. This is D. So in order for us to solve this faithfully without even considering the sign, so that the angles just give us a sign, we are going to measure this angle from the positive x-axis in the same counterclockwise. Are we together? So we are going to measure this angle. Let me just try to change color. We're going to get this angle. The one I've shown in black color, which is 210 plus 90 degrees, which is, let's call this angle phi. If we call this angle phi, it means our x component will be the magnitude, which was 25, cos 300. 210 plus 90, that's 300, right? 210 plus 90, that will give us 300 degrees. What is cos 300 degrees? Cos 300 degrees is going to give us 12.5. This is going to be meters. For the y component, it's going to be 25 sine the same angle, 300 in degrees, which is going to give us 25 sine that. My calculator is telling me that it's negative 21.65. Negative 21.65 meters, correct to 2 decimal places. So if we wanted to use this other angle, 210, if we wanted to use 210, using this angle 210 measured from this point, if we measure this, the x component, the x components should not be unequals. The x component, since this angle is measured from the y-axis, it's like we have twisted our axes. So this is y, this is x. This would appear as though we have twisted our axes. Let me even use red. Using the angle measured in red, the x component would be equals to 25 sine 210 degrees. Instead of using this whole angle, we've decided to use just this very angle that we are told that is being measured from the positive y-axis. So that this, since this, in this case, sine in this point is going to be negative as well, because the direction in which the x component is moving is negative, and we are using this other angle. So in this case, this is going to give us, we're going to add a negative there so that the component is correlating with our diagram there. So this would give us negative 1.5 meters. You can also add a negative there so to show consistent. Then in the y component, y component would be 25 cos 210. Since we are measuring this angle from this positive y-axis, and we know that this component, this angle coming from this point to that point, it is showing us that x is moving in the what? The positive direction. And we know that cos of this angle is going to give us a negative value. So we introduce this negative as well, so that this becomes, sorry. Instead of us going that far in, since this is measured from the y-axis, and we know that this value, this angle is 210, we may safely say that cos this is going to give us the component in the y-axis, which is 21.65 with the meters there. This has to be negative. So when you compute that 25 cos 210, it's going to give you a negative, and the y component is moving in the negative. Sorry, I think I left out a sign here. Introducing a negative sign here will cause this to be positive rather. Is that clear?
Yes.
Okay. Everyone else, are we together?
Yes, sir.
Yes, together.
Okay, thank you. And with regard to time, this is now 20:07. I think we are going to end here. And before we end the meeting, are there any questions or are there concerns where you need clarifications? Are there any questions from anyone among us before we end the meeting? I would consider everything is clear. Let me just try to see if I can find one more question that we can do in the next 5 minutes. the next 5 minutes, that is going to at least help us understand further. Okay, there is someone who wants us to repeat one more time, but instead of repeating one more time, let me just try to find a question that I can use that has got, I think, everything, so that we can at least try to tackle all of them at once. Trying to get a question here. Unfortunately, my question bank, I can't copy and paste. Let's try to go, let's go and make a scenario somewhere. Okay. So let's make up a question. We're moving from point A to D. A particle moved 4 meters in the north direction followed by 5 meters in the western direction and at that point it moved 6 meters rotating 75 degrees clockwise. Find the resultant displacement and the angle it makes with the positive y-axis. So I've tried to scribble that question. In moving from point A to D, whatever this point D is, a particle moved 4 meters in the north direction, followed by 5 meters in the western direction, and at that point, it moved 6 meters, rotating 75 degrees clockwise. Find the resultant displacement and the angle it makes with a positive y-axis. So, first thing first, in tackling this question, we go straight to our axis. Let's go to drawing the x or y plane. So, let's have for x or y plane. This is the y direction. This is the x direction. And from our geographical point of view, let's consider north is up there. So north is pointing in the positive y direction. So let's trace these movements made by this particle. So it says a particle moves from point A. So let's assume this point A is at the origin. At the origin, that's where our point A is. So from the origin, it moved 4 meters, 4 meters in the northern direction. So it moves 4 meters in the north. Let's assume 4 meters it is at that point. So this is 4 meters. Then it moves, followed by a 5 meters in the western direction. The western direction, this is the east, this is east, this is west. So it moves 5 more meters in the western direction. It means it just travels in a straight line. 5 meters in the western direction. Let's put the magnitude there. This is 5 meters. Then at that point, so it is at this point now, it moves 6 meters, rotating 75 degrees clockwise. Clockwise, it means it rotated clockwise in that direction, 75 degrees. So say we are at this point. So to rotate 75 degrees, 75 degrees from this point. So it is here, but it's at this point, 75 degrees clockwise, it will go to that point. So we're gonna try to draw my graph props. Okay, so what we have is that this line is the 0th degree. So it is rising at this point. So let's say we have a 0 here. 75 degrees, it's rising. So at this point, this is 90. So 75, it has to be along this line. Of 6 meters at an angle 75 degrees. So at the end of its journey, this particle is residing somewhere along that point. So I want to find the resultant, which is how far it has moved from the origin. So this is our point D. If we were to scribble a rough one, it would look something like this, such that the resultant, oops, the resultant would be something like that. So this would be our resultant R. This is D, this is A. So in order for us to fully solve this, we are going to do this with the aid of a table. But before I go into solving, is it clear on getting to the end point of this movement? Silence means it's clear. Eh? Well, let's try to so let's say X component, then we say Y component. Let's also say this should be our angle. And let's say this is the displacement covered. So coming back to this, at this point in the first part of this displacement, so it has three displacement. It moves from this point to that point in the northern direction, 4 meters. Then it moves 5 meters in the western direction. Then moves 75 degrees from the measured clockwise, at the end point, it moved 6 meters. So we have 3 journeys, 1, 2, and 3. So it means at this point you would have journey 1, journey 2, and journey 3. And let's say results here. So in the first component, it moved 4 meters. 4 meters in what direction? In the northern direction. Oh, I have 10 minutes. Let me try to be quick. In the northern direction. So in the northern direction, when you try to measure an angle from the positive x-axis counterclockwise, this guy would be what? 90 degrees. Is that clear? So this would be 90 degrees. So we would have 4 cos 90, 4 sine 90. In the second journey, it moved 5 meters in the western direction. In the western direction, measuring an angle from that to that, it's either 0 or 108. So in this case, let's use 108. So this would be 5 cos 108, 5 sine 180 degrees. Then it later moved 6 meters at an angle 75 degrees measured from the positive, measured clockwise. So since this angle is measured clockwise, the angle that we're interested in is this other angle measured counterclockwise. So we're going to get this angle, which is 180 minus 25. Oh, 75 rather, which is 105. We're going to get this 105 angle so that we compute the component of this in the x and in the y direction without thinking about the signs at the angles themselves. Just give us the signs. So this angle will be 105. So that the component in the x-axis is 6 cos 105 105. Then the component in the y-axis will be 6 sine 105. Then the resultant, which is R, making an angle, say theta, is going to be the sum of these dx's and the sum of this dy will be the components in the x and the y axis. But since we are told we want to find the resultant, so there is the resultant, the x component of the resultant, which is Rx, is going to be the sum of all these components. So we are going to sum these. So let me just try to be computing these. So 4 cos 90, 4 cos 90 is 0 plus, meaning that 4 movement had no component in the x-axis. So that's 0 plus 5 cos 180, which is -5, plus 6 cos 105, which is just giving us also -1.55, correct to 2 decimal places. The whole lot of this will be in meters. So when we add this, we have -6.55 meters, correct to 2 decimal places. Then the component of the resultant in the y-axis would be the sum of all these components in the y-axis, which is going to be 4 sine 90 is going to be 4. 4 sine 90 is just going to be 4. Then 5 sine 108 is going to be a 0. Then 6 sine 105 is going to be positive 5.80. Positive 5.80. When we add these two, we are going to have 9.80. But since 80, it has to be in meters, we want to find the resultant, which is this guy. If we can see, it's telling us that one of the components is in the negative axis and the other component is in the y-axis, because this is going this way. So this, it has a component along this guy, which is the x-axis, and the component along that guy, which is the y-axis. As we can see, we know that the x component is going in the x direction and the y component is going in the positive direction. And then the resultant, which is R, is just going to be the square of these sums. X component, which is raised to the power 2, will have -6.55 squared plus 9.80 squared. So the resultant, the magnitude of the resultant will be 6.55 squared plus 6.55 squared plus 9.8 squared. The root of that is going to give us 11.79. 11.79. Oh, I have 3 minutes remaining. This is going to be in meters. Then we are being asked to find the angle it makes with the positive y-axis. So this angle it makes with the positive y-axis. So in order for us to find this angle, let's consider this triangle that is here. So that's the component, the way it moves. Let's consider this. So the angle we are looking for is that. Let's call this angle theta. Then we have this as 11.79. Then this is -6.55. going in this direction. Then this guy is the y component for what? 9.8. 9.8. So using whatever cosine trigonometric ratio you'd want to use, you'd be able to find this angle. So I would think to use the hypotenuse and the adjacent in this case. So I'll say cos theta is equals to adjacent, which is 9.80 over the hypotenuse, which is 11.79. Giving me theta is going to equal cos inverse. These guys are going to give me what? It's going to give me 0.8312, blah, 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 blah. Use the whole number whenever you're trying to solve for this angle so that it gives you to some higher level of accuracy. Therefore, my angle is just going to be positive 33.78. 33.78 degrees. So the question was telling us to find the resultant displacement and the angle it makes with the positive y-axis. So in finding the displacement, just get this and express them as their components. Since this is just in the northern direction, it means it has no component whatsoever in the y direction.